This is a short introduction to the state feedback control of multiple input and multiple output systems. In these lectures, multiple input and multiple output systems are called MIMO systems. At the top of the paper, a block diagram is appearing, and in the central part there is a block with x dot equal to ax plus b and u, and there is a matrix with C on the right. So the input of this system is the input vector u of t, and the output of the system is y of t. U and y, that is the system input and the system output, are vectors, and it means that we have got not only one but more input and more output. The central block is x dot is equal to ax plus bu. The input of this block is the u of t, and the output is x of t, which is the state of the system. The state is usually a vector. It is appearing here. So we have got a system matrix A. It is usually a matrix, a quadratic matrix, but the input matrix, the B, is now a matrix, not a vector, as in the case of the SISO systems. So it is a matrix because U is a vector. And again, the output matrix C is not just a row called a row vector, but a matrix because we have got more than one input. And now the state feedback is performed by this matrix. It is denoted by K. It has got not only one row because we have got more than one input. And again, this negative sign is important because it is a negative feedback with this matrix K. And here I have to remember that this block diagram is the central block diagram of the state feedback control. There are some others, for example, taking the reference into account, or the integrator, or the observer. These three topics can be performed in the same way as we have studied in SISO systems. Okay, what about the SISO systems? SISO is, for recap, is the single input and single output system. In that case, we have got the equations in the green block. X dot is equal to ax plus b and u. Moreover, y, the output, is C transpose x. In this case, b is just a column vector because we have got only one input. And in y equal to C transpose x, C transpose is just a row vector because we have got only one input. Please remember it, and the difference between the single input, single output, and multiple input, multiple output systems. So in the case of SISO, we have got a K transpose feedback, and we have to calculate K1 to Kn, so we have to calculate n unknowns from K1 to Kn, and we have studied the Ackermann formula, which is a very famous formula to obtain K transpose, as well as the Basgura formula some lectures before. But now, because it's a MIMO system, we have got not a K transpose row vector, but a K matrix. And in this K matrix, as you can see, there are R rows and N columns. It means that we have to obtain somehow R by N unknowns, which can be quite a huge number. So here is the difference again between the single input, single output, and multiple input, multiple output systems. And for MIMO, we cannot use Ackermann formula or Basgura algorithm. We have to find out, we have to implement another one technique, and in the next videos I am going to speak about how to obtain the matrix elements of K. Just a very short recap. How does our system looks like again? X dot is equal to AX plus BU. It is here in the first equation. It's an ODE. And second, Y, the output is CX plus DU. And now I have to remember that D is equal to 0. And it means that D has not, so the input U has not a direct connection with Y, just through the ODE, through the state X. So our matrix A is an n by n matrix. It has got n rows and n columns. It's a quadratic matrix as usually. B is again a matrix with n row and r columns, and it means that we have got r input. So it's important the notation, because in the next lecture we are going to use n, r, m, and the other notations. So C is a matrix with m rows and n columns, and D is an m by r matrix. So in this case we have got m output, so the number of the output is denoted by m. So X is a vector with n elements, U is a vector with r elements, and Y is a vector with m elements in this case. So in the next videos we are going to speak about the steps of design of state feedback for MIMO systems, but how to perform it. There are three major steps. The first is the so-called Leuenberger type normal form. It's a kind of algorithm we have to do for the future work. The second step is the pole placement. For the pole placement in MIMO systems, we have to perform the Leuenberger normal form. And finally, we are going to speak about the observer design for MIMO systems.